Oh my god, I feel old. So, ladies and gentlemen, I'm Stringer, and this is going to be a quick stream to assemble the blower that I have just designed on Monday. The impeller was designed on Monday, it was printed, I think it was still like Tuesday, and then I have printed the scroll from two halves. This is the upper half, this is the bottom half, and yeah, I am printing the chimney here, which is going to be a duct that it sucks the air through, and it has like a not a chamfer but a rounded edge in the inlet, so to give it like a bell mouth that actually increases the air, air input by 15-20%, which is actually pretty lot, but just by that, for 10-15%. So what I will do is that I have already assembled this, but I will have to take it apart, so to fit the whole thing together. Right, I will need to take this apart, and I will put the things closer so we can see it. This is pretty big. The impeller is 150 millimeters in diameter, and the inner of this scroll is about 1/6 or 150 plus 6, so 156. But because it is like a progressively increasing size, how would you say this, circular, it on here on the side it has like 100 millimeters of radius or something. Yeah, I think it's 100. So here, so it starts from 56 here in the lip, and it goes up to 100 till here. It basically doubles from here to here. So right. Okay. You should have 6. Give me one. Alright. We have the two halves. This is the top, this is the bottom. You can basically tell because I have fucked it up in the design, but then I have corrected it. The bottom half or the top half has like more meat on the lip or on this thingy. Basically, they have, I don't know if it is visible, they have this little lip here, this rim that basically aligns them, so when you push them together, you put them exactly where you want them to. And that helps them to basically be aligned. Alright, so I need this. I need this guy first. Probably I will use this thing here, so I don't like. Maybe I should put these in. Still one missing. Alright, I will unscrew these quick. Yeah, I probably should have brought a flat bit, but I only did bring a Torx. I didn't have that here. Probably would need to go up to the garage. Alright, this goes, I think it goes here. Yes, because we screw it from here. Alright. I am a bit concerned because I think I might have fucked up the hole sizing. Yep, I might. I actually I missed the fucking holes, which is not good, because this would be needed to be at this radius or so. I think so, but the holes got to be off-centered. I don't know why. I missed the hole placement for some reason. I have put it actually. Or might have I? Oh fuck. I might have fucked it up because it might have been inner not outer, and I might have moved it to the wrong direction. Oh my god. So yeah, this was what I have been thinking about in the last few hours, because this has been done for quite some time now, and not too good. Alright. I'm not going to get into like crying mood like yesterday, or I think it was one day before when I thought I fucked the sensors. Am I just going to go and place a hole or something on it? Maybe I will mark it out and then drill it out. Because this is not that bad, I think. Yeah, sure, the holes. Although, one thing I mean, it's not going to be that big of a deal, I think. I think I can put them so that this is this. We will be able to do that. We can put it here. There's still plenty of space. Alright, this is it. Yes. Okay. I will take a marker if I can find it. I might will need to. I don't know how I will be able to do this. It's pretty hard with one hand. Fuck you. Ah. It doesn't touch the fucking thing. It doesn't reach in. Oh my god, come on, man. This is a joke, isn't it? Alright, let's find another one. Hopefully that has a longer. I am afraid that these don't fit. No, they do not fit very well. What the fuck do we do? Does the pen write on them? Let's see. Probably not, but I will give it a try. So yes, this is the after effects of like poor design that you need to. I'm not going to fucking reprint this, no. I'm not going to reprint this. Fuck that. Maybe I will put the little block under it so it doesn't fall down. It is something, but not too strong. Fuck off. Let's say it's okay. Now that this is okay, great. here's alright, we have, I don't know, maybe, oh, I didn't check one thing. I did not check one thing, which is that if I drill it, will I be able to, also, where is the mark here? Will I be able to? Alright, I will be able to, okay. Check on Yep. So I will need to somehow drill out these holes. I hope I did not. Yeah, here it is. Here it is. I don't know what should I drill it on? Because I'm going to drill it on something. Maybe on this, but this is too small. I need a box or something. This is feel kinda like when I was younger, and I mean I'm still young, but you know, younger, that I was playing with Lego and all that stuff, and I was actually building. Get this on my head. I'm gonna need the drills. I hope I have small ones, not just these big fat fuckers. I'm afraid I don't have smaller ones. That's not too good. I don't want to go up. No. Do we risk it? I think we can. So actually, put in the drill bit. No, fuck you then. I won't put in the drill bit just yet. The chuck is too big. Ivan! Yo! So much for the building. Always have to go, man. Can't take a shit. Tessék! Milyen doboz? Oopsie. Yes, I'm back. So let's get to the catchy part. But now we will drill the thing here. Alright. Actually, Alright, one is done. Let's go to the next one. And the last one is here. I hope I don't have to drill out that much. Yeah. Alright. Alright, how the fuck is this? I think I have to put this over here. And I don't think this is the good one. I think this is the good one. This is the good one. And I'm going to just drill the third one. I'm just going to put the two holes in, and it's just a shit hole, shit show. Or no, not this one, the other two, because they are the screw head and I want to change the chuck. Yeah, finally can. Is this a fucking joke? Oh my god. It doesn't go through, does it? Of course it doesn't. I don't want to drill it with a bigger one. Oh my god, come fucking on. And I will need to... Alright. Where's the head? Hello? It's interesting. Oh. Oopsie. Okay. Take this and which one is my hole? I think this is it. What is the? I can't tell which one is which. I think this is the. I think this is when I drilled and this. I think so. Right. No more free. Need to. Alright. Take it in. 16 will go. Okay. Go. Okay. I think we can still move it. Alright. Yeah. Turns out it's almost good. It's almost perfect. It's almost perfect. Yes, I know. What is this annoying sound? Is this going in? Oh yeah, alright. Great. Alright, I might going to trim a bit on the third hole, but I don't care that much. So this ring is going to hold the placers for the basically I'm just going to show you if I turn this in. So this is going to be the impeller, which is going to blow the air through the whole scroll. There's two halves of the scroll, which is this is the bottom, this is the top. They sit nicely together. But the one little problem with this, if I put the impeller on the motor, then it is going to still be able to wiggle up and down, and to basically fix the casing, the scroll to the motor and the impeller to the motor. If they are both fixed to the motor, if they are both spaced, then it is not going to be able to hit either the top or the bottom of this scroll. So I'm just going to I don't know, maybe I can cheat it a bit, so I might need to drill it, but I don't want to drill it, oh, I can't even. Yeah, the problem is that it is a bit off center because I hand drawn the holes now, so to cut them. The only problem is that I am not the best marker, my hand was wiggling because I did, as you can see that there are like holes. These little holes supposed to be the ones that I use for the for these screws, but actually it is coming through. I never mind, I didn't say a damn thing. Just going to screw this last screw in, and then I'm just going to basically this ring is going to be tightened now with the last Torx, and I didn't find it. It's just put the thing on. One of my friends got like some bits, or I don't know what, spun out of just one chuck, and basically there was like a little shaft. Basically the shaft went into his fucking eye. They basically got the eye, but he basically somehow managed to get still I don't know, not the liquid didn't come out of his eyeball, but then he went into the ER with the emergency room, and basically they used like a little needle, and they basically stitched the fucking eye. So basically they sprayed him the eye. This is disgusting, but you get the point that sometimes I think about that. Fuck, he barely got his one eye. So I mean he barely lost it, but fuck me, that sucks. Whatever. So so going from here, the next step is, I think, the bottom of the scroll, which is this. The bottom of the scroll should sit on here with the little legs attached to it. We'll screw in the legs somehow. Maybe I shouldn't have told that story. Whatever. So, putting in the screw. I think I will. So I'm actually assembling this. This is going to be pretty. I don't know how I do it. I have just assembled the motor with the hole there, and I'm going to somehow screw this onto the because I don't have a chuck here. It's going to be pretty shitty, but I'm going to try still. Regardless of that. Oh, maybe I'm this. Fuck. very bad, very bad. So maybe this way. It's not going to be. How the fuck do I do this? This is the hard. Maybe I have an idea. So maybe I should drill this in somehow. This is very annoying. These little parts are the most annoying to get. Is this on? Alright. I will push this a bit. Okay. Hope I will be able to. There's two possibilities. One is that, let's see, and the part is too much. At least I think I was able to get the everything through. The only problem is that now I would have to somehow tighten it. And maybe just hold it somehow like this, so that it sits still. It will, spin the fucker out of my hand, of course. I will need some tool for this. Alright. Sort of okay. But I don't know which is which. I think this is uniform in terms of like diameters and hole placing, all that kind of stuff. Need the next screw. 3 of these. I have 3 legs. 2 more to go. Alright. Alright, this is so annoying. What the fuck is this? I'll be right back. I will have to check the fucking printer. What is this noise? Oh, I know what is this noise. The spool broke again. I think. Are we printing anything? Oh yeah, great! How lovely! Oh fuck you, man. Oh great! Great. I have to restart. Sorry, one second. I have to restart my print because I don't know why. I just sometimes the printer just breaks the fucking filament spool and they basically just the head is just I should have checked when I started this spool first. I was so glad that I started to make it. Nothing wants to work. I mean, sometimes you have to suck cock a few times, and sometimes the amount of sucking is due to one period of time. Sometimes there are good periods, sometimes there are bad periods, and everything ends eventually, just sometimes are worse than others. So I guess we can only control what we do, not what we get. Because suction is that. And when you do things, then it's even a worse factor. Can't even get this shit off. Oh my god, come on. Thank God he didn't do this later on. When I would have slept, because then the whole print would be shit. I mean, not the whole print, but 80% of it. Very annoying. Fuck off. Sorry, I'm just cleaning off the debris, so you have to wait. It's, I don't know, 2-3 minutes. Let's see if I can get this shit back up. Still want to stop printing the chimney, because the chimney is very important. You know, the chimney is the duct that the top part, the top scroll part, sucks the airflow, and it basically like helps the airflow to how do you say this, to straighten out, because if you were just to suck the air through the top just as now, it would be highly uh, swirling and all that kind of stuff, so it would be very non-linear and turbulent. That basically is not good to any turbo machinery or any device that works with like centrifugal kind of stuff. Like how do you say this? Centrifugal kind of technology, but like a way of operation. This fucking support material is so goddamn stuck to the base plate that I can't even get it off. This is annoying as fuck. Is this fucking serious? I'm off. Oh, fuck you. All this junk with this shit. You're just so stuck to the fucking base plate, can't get it off. Whatever, fuck the whole thing. Fuck the whole thing. I just do not care. Is this? Fuck. Alright, start cleaning. 6 hours from. Bruh. Oh my fucking god. It stopped at like 1.5 hours. Oh my god. Whatever. What the fuck? So, whatever. So, I'm gonna continue this assembly at least. Hopefully I will not break anything here, so be able to continue to finish this. So the thing I would need to mention is that this will not be a fully finished version in terms of build. The whole system was designed, I mean not designed, I just made it. Unfortunately I didn't really have the time or the bandwidth to simulate it. I don't know if you know about like CFD and all this stuff. Basically it's like aerodynamics and fluid, but it's not combustion but like fluid mechanics, whatever. So basically you take like a known geometry like the impeller and the house, and if you were to be really interested to maximize how the given flow, I don't know how to say this, not delivery, flow. If you want to maximize out the flow rate per given power that the motor puts in, then you would definitely want to CFD. CFD is kind of like a on this and all that kind of stuff. Very useful stuff though for turbo machinery and all these. Even oh, I have to tighten this as well. Turbo machinery and all that. I will have to collect my thoughts here because I can't really do two things at a time. I'm pretty brain dead. That's why I can't say like a complete sentence. Alright, we have the spacer legs. Now I will, it's kind of like a leg, I mean 3 legs to be honest. So we have the motor. We are going to put the how is this? The motor is going to have the little plate, which I will have to reprint because I have drilled the center hole because I didn't think that this center shit is going to like bump because it is taller than these little pins. So basically the flat plate sits on this, and put this on, put it on the impeller, get out the screws because I don't want them to spin out at like 5000 RPM. I have a few screws somewhere. Here they are. And no, before I put this here on to the pin here, and I realized that I might have fucked up already. Not good, not cool. It's actually longer than it's supposed to be by 3 millimeters, which is not too good. Not even 3, it's even more. But how the fuck? I measured something wrong. So much so for the fucking... Oh my god, come on. Yeah. Come on. 3 millimeters and even more here. Yeah, these legs are too long. But why the fuck did they... Oh my god, why did I measure... No, I should have not listened to the fucking model. I should have listened to myself, to my calculations. It would have been enough to make like fucking 50, 52. What is this? What's this? Sorry. Fuck. Whatever, I'm not going to bother with it, sorry. It's just a fucking retard fucking camera. Whatever. So, yeah. Actually, I have fucked up the designing very well. I mean, not very well, very bad. Because I can't assemble the thing now. I mean, I can show you it spinning, at least then like something like visual to see. When you put this on, this can spin at like pretty fast. I don't know how the RPM. It would be able to blow. I would just need to remake the legs, or if I am really advanced, like but then they would not be uniform. Is the point? I actually could, because look, I have the legs here that space the whole what is this? This scroll bottom from the impeller and the bottom of it. But the problem is that, I don't know if you can see, but the bottom of this is supposed to be higher than basically this flat surface is supposed to be higher than the internal of the whole scroll. So to keep the impeller from the scroll bottom about 3 millimeters of a height. The only problem is that it's not higher but actually lower, which is a big problem because this is supposed not to touch it. Because if this touches it, then it would heat up. And I mean, I could technically turn it. The only problem is that it would just melt the bottom with the friction, which wouldn't be too good. Oh my god. So I would either have to cut down from the legs or reprint them, which reprinting is not going to happen now. Should I stop the current print? It's not printing yet, I think. So I might need to do that. Because this is not good. I will need to fucking redo this. But if there's two chances or two options here that I could do. This is like real designing that I have actually modeled the thing and I have calculated with hand. And even when I was like reading the distance from the base plate to this shit with in the CAD software. I was like actually curious because it was on paper. What the fuck is this again? It's supposed to be like 50, 52 or 53. I think it was 53 millimeters. So 53 millimeters was, and this got to be 59 because I believe the cat, but actually the cat was wrong, not me. This, sorry. What is this sound? No, this is not the. This is the stepper actually. Curious. Are you fucking printing at all? I'm not sure. I don't know. What the fuck is sticking? I don't know. My printer is falling apart. This is fuck you. Shit. Utter fucking dog shit. Garbage. Ah, come on. Alright. This is a fucking shit show it is. Neither does this work now, the fucking printer. Oh my god. Very well. Fuck me. Well, oh, fuck it. I'm just going to show you my utter messy shit. Utter messy shit room. Here it is. Here is the mess. The fuck did I put my stuff? Right, here's the mess. And here's the good old printer. At least I'm going to show something whilst I'm sucking cock with it. Great. Yes, this has been bent all over the place. Great. Cut it. Maybe here. Let's see. Purple fucking shit. Where's my... I hope it will not take now. It's just annoying as fuck to listen to this utter garbage. What should we do now? I would need to measure out the distance that I need to be able to measure out the distance to be able to, I mean, roughly, I think 3-4 millimeters. Let's say this is like 4 millimeters because it's almost touching the bottom of this. So let's say 4 millimeters ish above to get to this, and 3, which is exactly 3 plus 4, which is 7, which is how much it was actually longer than supposed to be. My god. I think I will reprint these legs. Will take less than they did the last time, but at least I will be able to fix them, because they will work fine. The problem is just that it will not be on the correct height. So I will go into the CAD files and adjust them, and instead of the fucking chimney I will start printing this. Or let's see, I will start printing them out. Come back. Solid edge, man. Chimney, motor leg, let's put it to, what was it, 59, 4 and 3, that's 7 less than it's supposed to be. So instead of 59 we go for 52, 52, alright. How deep these holes are. Okay. Alright, we don't show it, fine. Okay. Fuck. Yeah, bolt. This is it. This is 16. Alright, this is good. Okay. Save. Nastia. Motorman. Override. Kura. Direct chimney. Fuck you. Wrap. Get the leg. Get the leg out. 52. Okay, this is it. Turn this bad boy. We need actually 3 of them. 1, 2. This is 1, 2, 3. Alright. Okay. Okay, slice. It was 2 hours and 50 minutes last time. Now it's 2 hours and 36. Not too bad. I mean, compared to, it sucks that I needed to fucking reprint the whole thing. It sucks. At least we have a nice little leg. Yeah, I mean, technically I could put some washers here. Yeah, sure. Yeah. Just I don't know if I have like washers that would be that would be the same thickness. Maybe I will start looking for it. No, what time is it? It's sorry, 36. Oh. Yeah, I mean, the problem isn't the washers. The problem is that the washers width. Because if the washers are not the same thickness, then they will wiggle around all over the place. But for yes, that's a good idea. Because I thought about like making like a same thickness something, but I need 7 millimeters worth of washers, at least 3 plus catchy, because the only thing that is keeping the thing centered. I mean, I don't know how tight the screw holes are. I might not be able to test this today, because the screw holes are kind of, they're kind of tight, but not airtight. You know, you get the point that they can wiggle and wobble. If I put like seven millimeters under it, it's going to be very sloppy. 7 millimeters. What the fuck did I use for 7 millimeters? We'll look for something or some shit if I can. Sorry for not responding to the question. I didn't see them. Like suggestions, yeah, sure, good point. I know. I have this shit, but I don't think this is. Too uniform. 7 millimeters. 7 millimeters is a lot, by the way. So 7 millimeters is like how large is my calculator? 7 mil. For reference, that's double this height. This much. It's supposed to be higher. So this is not too. This is perpendicular. So I don't think I do want to do that. It's going to. I mean, for now, for just showing the whole thing, I can show you the thing so you don't came here for nothing or something. At least I will show you the thing. I will assemble it and then call it a day. Tomorrow, I think I will make another stream in the morning to finalize this shit after I clean the chimney in the evening. What time is it? 7:39. I will finish the parts if the printer wants to print as well. I will finish the parts till like 10. I will be able to start printing the chimney. It will be done in the evening, hopefully. I am not sure, but if this test will go fine, then I will start the chimney as well. If it will shut down, then I will have to come up with something. Fix that. Yesterday I fixed the fucking BL Touch. It was shitting itself. So I will show you something at least. I will show you the thing. I mean, it is actually called it a mini helicopter because it was actually pushing a lot of air all over the place. It will be very useful for the burner that I'm making in the future, in the close future hopefully. This will be necessary because I have another one which I will show you in a quick second. Just screwing these in. I will need to take like a star-headed bit with me next time because I only have like a Torx head. That's only good for one screw. All the other screws are all star-headed. I mean, yeah, sure, these are as well. These are Torx as well. No focus. Yes. Fuck. So yeah, Torx. So here is the other blower, which I have already mounted the measuring device to. This is the little blower. This is from an old Barkas. It's like a NDK bullshit from like I think that's this Eastern Germany built blower, which is just a regular fan, and they have retrofitted this car fan. I made this little thing. Yeah, but I think it's even the impeller in this is like 80 millimeters big. This is 150, so it's almost double that. And this is pretty shit in terms of geometry with the scroll. This haven't been. I mean, I will say that I haven't tested it in CFD this either, but I am pretty sure that this will be working a lot better than this little shit. Focus F, yes, of course. So yeah, so I don't know if you know about this. Basically, in the future, I will wanna make the fuck. I'm brain dead. So I want to make the burner, which needs fuel, that's oil. It depends basically what you want to use. I have made, or I have thought to myself that I'm not just going to make it to either, I don't know, diesel or kerosene, whatever you want, but actually to be useful for multiple types of fuel, to be able to burn diesel, vegetable oil, car oil. Of course, I will add the exhaust gas cleaning devices, because if you burn car oil, that's like supposed to be illegal, but don't tell the law, the legals. But if you add clean up things, basically that you, when you burn the I have nothing to show here, just when you have, yeah, when you burn the car oil, the used motor oil, then the motor oil will basically emit particles with it that are like, I don't know, heavy metals, I think. And they basically, you can catch them and collect and clean the whole gases, but of course you need like certification and all this bullshit. But if you don't have the certification, at least make sure that you have the fucking thing ready and like nice, and also you test it out. So that's the like the first step. So basically to before I test that, I will have the gas cleaning. But what I wanted to tell all with this is that when you have a burner, you burn fuel, but when you burn fuel, you need a certain amount of air, which is called a air fuel to air ratio, or stoichiometric ratio. Yes. I mean, if I wanted to really nitpick, then I could CFD simulate this and iterate till it was the best in terms of like airflow rate and the pressure drop, like the least pressure drop and highest pressure ratio output. But the problem is that I didn't have the time, so I might do it in the future if I want to like optimize the geometry. But for now it will be better. We'll see, though. I don't know how much air it does produce, so this is like a bad thing, and that I didn't design that, I admit. So to the burner, you need actually a given amount of air per given amount of filters, and there is one thing that is called I mean, you strip them. Basically, you take water, that's lime water. You take the emission gases, you clean them. The particulate matter is a bit tricky. You use a cyclone, which is like a big. It's like a Dyson. Basically, you have like a big chamber that has like spinning air, and because of the mass and the inertia, I don't know what they call it in English, the inertia of the particles, it basically it spins out to the wall, and because the wall has like this surface that is like, I wouldn't say rough, but you know, has surface, and it has friction there, the particles will rub on it, and they will basically slow enough so that they will fall out of the from the circular motion. And that's one thing, cyclone. But under it, I think that's good for like ppm, so particulate matter 2.5, which is 2.5 microns. Um, I don't know if it is radius or whatever size. They call it 2.5, PM 2.5. The other one is then 2.5, which is called the ESP, which is an electrostatic precipitator. You have two plates. Basically, the gas comes in, which is like laden with all the bullshit particles and all that. And basically, you push the. You can do it AC, you can do it DC as well. It depends which you prefer. But it has high voltage, kind of like 5, 10, 15,000 volts, but it has very low amperage. So basically, it is kind of like I don't know if you heard about Corona. Basically, not the virus, but the Corona effect. Basically, if you have like a pole, electrical pole, there are these very massive 150,000 volt electrical poles that carry high voltage lines throughout long distances. They make this bzz, bzz, bzz sound. This is like kind of like transformers, but when there is a rain, you can actually see that they have like little purple lines. Basically, that is because the the air is just leaking the current. That's the same thing here, because you have one plate, and that plate leaks current, which will charge and ionize the incoming dust, or you can call it PM, whatever, and it will charge those particles up, and the particles that take the charge, basically they take the electrons there, they will be attracted to the other pole of the plate. And as they go through the whole system, the particles, the gases that cannot pick the electrical charge up, they will go through it, basically like carbon monoxide and all those stuff that are gaseous. The particulate matter, on the other hand, will pick and get like I think sulfuric acid, sulfurous acid. All these can take up charge because they can be charged. I think SO3 groups, SO3 minus some whatever. So they come in, and the particulate matter and all these things pick up the charges, and they attract to the other pole, other surface. And there is a lot of surface inside this ESP, electrostatic precipitator, and that basically collects like sub 2.5 to like, I don't know, very 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 fine particulate matter. So it is like very clean, but it can do very small amounts of particulate matter per given area. So a cyclone is more for the big, higher, higher volume, coarser things, and the ESP is for lower volume or lower particulate matter, but and also lower amount of them. So yeah. The burner needs back to the point. The burner needs a given amount of air to burn the fuel cleanly, so we produce the most amount of heat per used fuel, and for that we need to measure the output of the blower. But I want to automate the whole thing, not just set it once and then it's good for now, because any system, if you run any system, they are dynamic, meaning that the parameters, the conditions change in time. Therefore, if I don't know, the temperature drops a bit, or I don't know, the voltage drops a bit, the burner has a bit of choke because of something. Surface, I think they are just stainless steel plates. They are just kind of like the electrolysis plates in like a DC, electrolyzer. They are just plates inside that there is like, I think it's kind of like one plate is up, one plate is a bit down, so it's kind of like this, and the gas has to go through like a zigzag motion, and basically it 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus, I think something like that, but I'm not sure. I don't know that exactly. I haven't checked that. I am only going to do this to basically be able to set the to know, because I will want to use this or either this, probably this, the other one. I don't know if you heard about PMW. PMW is like you have like a microcontroller, if I can find him. Just have all the fucking wires hanging out. Don't want to break anything. So I have like the microcontroller. So there's too much space. There's the microcontroller here. This is the ESP32 based, kind of like an Arduino Uno. Basically, he will control the whole burning chamber and burner. Basically, first we want to set the there's like a PMW, so basically he will control the blower. He will send the signals to a board that will adjust his power. So we can set, let's say, 50% duty, that means that it spins with 50% speed. And if we say 50% speed, we will have to measure out what the amount of air it does. We will need to measure out a few points, let's say 25%, 50%, 75%, just rough numbers, these are not the actual ones. It's a bit different than that, how you do it. But when you measure out the points and you measure out the pressure drop, Basically this is like an orifice plate inside, meaning that there is two rims here, that's it, and there is like a plate kind of like this. It's like a hole with basically it's like a rim. It's like a flat disc with a hole in it. Basically it creates pressure drop inside the tube, and across the pressure or this known amount of distance, so there is like a, sounds good. Yes, ionization, of course. Yeah, I will have to look into that because I haven't really I have looked into it briefly, but I haven't started to make them because they're actually kind of interesting but hard to make. And yes, you can like I don't know how do you say this, sharpen the edges, right? So what I wanted to say is that I will measure the drop across this known diameter of hole, and then basically the difference of pressure between these two little poles or two little pipes will determine the flow rate. Basically from that we will be able to calculate for like a 50% PMW, which is 50% speed, it will give us something, and 25% will also give us something. Let's say the 50 will give us 1000 Pascal difference, the 25% will give us 500% or 500 Pascals worth of different pressure, and based out of that we can calculate how much flow rate does this little bridge produce, and then we can use that to feed into the VMOS or the ESP32, and with that data we will be able to predict it's called the feed forward, basically that you send the signal to the pump, it pushes in a certain amount of fuel depending on how much steam you want to produce, and when the fuel is pushed in, the VMOS knows exactly how much air it's supposed to push in as well, and based on that it will set the RPM of this with PWM, of course. Yes, that's the point. And then the steam is going to be used to produce Fischer-Tropsch, which is like synthetic fuel making, but to heat up the Fischer-Tropsch in the beginning, but then you will need to cool it down. So he will start to produce his own steam. I will spin this bad boy up. I hope he doesn't have too much shrapnel in it, because last time he had a bit, but meaning that I'm going to turn the camera. I'll take it here. At least I have a power on my little PSU here. Alright. Actually it is backwards, because this I don't know why, they usually are counterclockwise spinning, the motors, but this is for some reason is a clockwise one, and I have designed the impeller for the other one, which is counterclockwise spinning. This is clockwise spinning, so if I were to hook it up like a normal one, so plus to plus, red to red, black to black, or black to brown, then it will actually not work as well, because the blades are forward curved. If you want like a turbo, I have looked into this actually, that if you want like a proper turbo, which are in cars, they actually have backward curved blades, but they are only good for very high RPMs, like tens of thousands, hundreds of thousands of RPM. At that point, when the air is becoming actually incompressible. For this, the forward curve is actually preferred. They use like squirrel cage designs, which is actually like this. So I have this little shit here. I have 12 volts hooked up. I'm going to set it to, I think it was 8 amps or something like that. I will limit the guy for, I think, 8 amps. Put the thing off. Nothing is, nothing is here. Let's see. It's a bit wobbly. We will check time to see if the knife is tightened. Don't want him to fucking spin the whole thing off because I is drawing 34.5 watts, a lot actually. I don't know if there is anything here that we could actually show that how much air it pushes. Probably, I don't know. I mean, if I had smoke, that would be the best, but because I'm inside, I don't want to gasify myself, so I really hope you do understand. I don't know if I want to doing this in. I mean, I can tear a bit off to see how much it actually pushes. Yes. Shut him down. He took the paper in. Didn't. So whatever. This I think the printer is working now. Oh hell yes, sir! The printer is doing its job. Actually now it isn't dying on me, so that's a good thing. So yeah. Gentlemen, I think this was it for today because I cannot complete this shit and I don't want to waste your time here. It's been a pleasure. I will take myself to the gym outside and I will do some, pull-ups today. So if you want to check in, I don't know what time zone you live in, it will be I'm not sure what time, but I think something in the morning, Budapest time, what's that? You will get the notification on here if you subscribe. Subscribe to my channel, guys, please hit the like and subscribe. So yes, this is CET, this is CET 2011. Budapest zone. So if you are interested, subscribe to my channel, please, guys. Actually, I really need it. So whatever, don't give a fuck. But if you really want to see, enable the alarm bell. No, just kidding. So whatever. So the point is that I will not be able to finish this because I don't want to spin this with the washers. I'm sorry. sorry to say that, but. That's I think that's too dangerous for this at this RPM, even at low RPMs, because the washers are really thick and they can basically wobble, so there is nothing that is holding the whole thing together. The only thing that is holding the thing together is that the friction here between the two plates and the screws. I was actually thinking that I will reprint the little thing. I will disable the motor before, or like take the whole thing apart before I somehow accidentally turn it on and like take my half hand off or something. So I will take the guy. I will actually reprint the bottom plate, which you have seen. I mean, if I technically, now that I have thought about it a bit more, I could have actually reprinted the bottom plate to be a thicker material on here on the surface, or have like higher legs, but I think this will be the best, so that this is constant, because the hole here is not too centered, it is a bit off. Right. I don't know. You can see that there is like a more space on here on the edge, which actually creates what is this mass imbalance, but it's not that significant. This shit is like 287 grams. I mean, it was in, when I printed it out, so probably half 50 grams of support material fell off, but even then it is like at least like 200 220 grams, so this is pretty heavy compared to the other little shitty one, which is at least good in that sense that it you know, the bigger the mass, the less deviance it creates if there is like a little error in it, because the other mass will like compensate for it, so to speak. So yeah, I think this was it for today. I will come back tomorrow in like, I don't know, 8 in the morning, 9 in the morning. For me it's like 8, so 12 hours from now I think I will be on. So I will finish the bitch then, hopefully. The legs will be the right size. I will be able to take them or put them together. I will also put in the chimney, which you haven't seen. I will just show it quickly. I will send it. What is this? The Solid 8 motor. Alright. It's going to be very poor man thing, but I'm going to show you the fucking screen like that. Of course you'll freeze on me. Oh fuck. Not good. Oh my god, the camera died. Fuck no, come on. Oh my god. Alright, so I'm actually back. And yeah, actually back. We'll show you this. This is the blower. This is how it's supposed to look. This is the chimney on the top. This is the two halves. This is the motor. I have fucked up something with this. Maybe the distance here is not good. It's supposed to be 7mm shorter, so fuck. Whatever. This part, the chimney, will be printed in the night, and I will assemble the whole thing tomorrow. We'll test it even. If I take you to the toilet where I have built my little assembly line here, I had this little very shitty manometer because I don't have the pressure sensor yet, which I have actually ordered, but for them we have this little manometer here, YouTube. Basically, I don't know if you know this, there's like water in it, and if you push the water, because it is incompressible, you can basically check the pressure difference between the two with like the difference height in here, and that the difference height will be able to be converted into difference pressure, and the difference pressure will be converted into volumetric flow that we actually want. We will be able to, with the microcontroller, we will be able to tell with basically manually, in the lack of pressure sensor, what actually a few PMW signals are, or at least have some clue about what the blower can produce on, like, I don't know, 50, 70, 80%, to know at least if it is actually any good, or can I just actually throw it to the trash, so to speak. And of course I'm not going to throw it to the trash, but the motor will be extracted, and the rim is going to be reused, because this measuring orifice plate design is actually good. I will have to make a adjuster and like how do you say this, converter to this, because I have this hole is 45mm in diameter, the hole here, and this is actually 57mm inside, so I will have to adjust for that. But yeah, this was it for today. I will leave now. I will go train and go to sleep. But thanks for watching. I'll see you tomorrow if you come. If you don't, then you can check it out later if you want. It will be on the live streams sections on my channel. So yeah, thanks for watching and tuning in, and thanks for the comments, thanks for the questions. See you tomorrow. Goodbye. and good night.